everybody, and welcome to this video on the geometric series. In this video, we're having a look at the difference between a converging and diverging geometric series. So over here in green and red, we have two types of geometric series. The one in green has 1 plus 2 plus 4 plus and so on. Now you would notice that each following term gets bigger than the previous term. So that is what we call a diverging series, when each term becomes bigger and bigger than the previous term. For the red one, the converging one, we have 1 plus a half plus a quarter plus and so on. And what you would notice in that pattern, each following term is smaller than the previous term. So how will we determine mathematically, or what is the criteria to find out whether a geometric series is diverging or converging, is to look at the R. The R is the ratio between the terms, which is any term divided by the previous term. If the ratio is either less than -1 or greater than 1, then our series is diverging. So it will get bigger and bigger. If our ratio is between -1 and 1, then our series will be converging, as in get smaller and smaller. Let us have a look at an example to see how these principles are applied. So here we have an example. Are the following converging or diverging? So like it was mentioned before, to find out the answer to this question, we have to calculate the ratio. We can calculate the ratio by taking any term, dividing it by the previous term. So T2 divided by T1, which is 4/16, which is 1/4. Our ratio is between -1 and 1. Therefore, this pattern is converging. Let us do the next one. So to determine whether it's converging or diverging, we have a look at the ratio, which is any term divided by the previous term. So here I'm using 3 divided by 1, which is 3. 3 is greater than 1. So in this case, our R is greater than 1, which is the criteria for a diverging series. Let us have a look at the next one. So here we have R is equal to, I'm now divide T3 and T2. You can divide any one by the previous term. I'm just choosing the one without fractions, and then what we get is 5. Once again, our ratio is greater than 1, so this series is diverging. Let us have a look at the next one. So the ratio is T2 divided by T1, which is 8 divided by 2, which is 4. These two terms have been actually swapped around. Can I just fix this, please? Sorry. I've written those two the wrong way around. It should be 4 and then 2. So then what we have is 4 divided by 8, which is a half. So our ratio is between -1 and 1. So this one here is converging. And finally, the last one we have, our ratio is R2 or R1, 3 divided by R1 or R2. So in this case, it's 0.05 over 0.25. So 0.05 divided by 0.25 is 0.2. And 0.2 lies between -1 and 1. So once again, this pattern is converging. I hope that you've understood how to identify with a pattern, sorry, my voice is going, is converging or diverging. Please watch our other videos for more information.